Welcome to the walkthrough of the specification, skeletons, tests, and sample application of Assignment 1A. The objective of the first part of this two-part assignment is to give you experience using Android Studio to develop and test an implementation of an array interface written using Java's object-oriented features. It's important that your array implementation work properly since variants of it are required by all subsequent assignments in this course. The code you write for this assignment has a GUI and runs as an Android app. Please feel free to use this app to help debug your solution. The following resources may be helpful in completing this assignment: the Java Utils Arrays documentation, which provides certain useful methods for your array implementation, and the Java Oracle tutorial, which provides a good overview of Java's object-oriented features that you'll need to implement this assignment. If your Java knowledge is rusty, you might consider watching the videos in our Coursera Java for Android MOOC. Before you start with Assignment 1A, you'll need to do the following things: download and install Android Studio. The instructions for doing this are available at this link. Set up an account on GitLab, which is also explained at this link. The Image Crawler app is packaged as a project in Android Studio version 3.4. The app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1, however, you only need to be aware of the following three directories: the Utils directory, which contains the skeletons you'll need to fill in, as described shortly; the test directory, which is a set of JUnit tests that exercise the features under test and can be used to evaluate whether you've correctly satisfied the assignment's requirements; and the Android test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio Interactive Development environment, which should automatically select an Android emulator to run, assuming that you have one created. The application's minimum API is 26, so you'll need to select an emulator that uses API greater than or equal to 26. Although I recommend you use the emulator that's associated with API version 28. If you don't already have an emulator created, you can create it by clicking on the AVD Manager button in the Android Studio IDE. An array is an abstract data type, or ADT, implemented via a single contiguous buffer that provides operations like get, set, add, remove, and size. Your task is to implement a generic array class in Java. This class will be different from Java's built-in arrays in various ways. For example, it can be resized and used in conjunction with other Java collection framework classes. You'll need to modify several files containing the Java skeleton code by completing the to-do you fill in here tasks to provide a working solution. Whatever you do, don't change the overall structure of the skeleton. Just fill in the to-do tasks. In particular, you'll need to finish implementing the following to-do tasks for the assignment in the utils folder. First, there's the unsynchronized array.java file, which contains the unsynchronized array Java class, which implements the array interface. You'll need to complete the to-do task in the various method to implement this particular class. There's also an assignment.java file. You'll need to complete the to-do statements there in order to set the S-types field to either graduate or undergraduate, depending on which version of the assignment that you're implementing. This particular setting will be used by the unit tests to make sure it tests the appropriate part of the code properly. Grad students, or students who are taking this course for graduate credit, must also do the following additional work: implement the requirements of the iterator interface. As much as possible, you should avoid using loops in this assignment and instead use the arrays copy of and/or system.arrayCopy methods. This isn't possible for all parts of the code, of course, but make sure you try to use it as much as you can. The skeleton code for this assignment is available at this link in my GitHub account. Once you've set up your GitLab account, you can pull this skeleton code in your repository, read it carefully, and complete the to-do markers. The additional work required by grad students is clearly marked and also described later in this video. The JUnit unit tests are in the image crawler folder under the tests directory. These are provided to increase your confidence and our confidence that your implementation is working as expected. You'll need to learn how to use the Android Studio GUI to run the JUnit test locally on your computer, as described at this link, and also described shortly in the video later. As usual, testing only demonstrates the presence of bugs, but not their absence. So don't rely solely on the JUnit test to detect problems in your code. This assignment is intentionally designed to be easy to help you get familiar with installing and using Java and Android Studio. If you find it's extremely hard to complete this assignment, you may not be prepared to take this class. You may need to take certain other prerequisites first. If this turns out to be the case, please meet with me as soon as possible to discuss other options. Now that we've talked about the specification for assignment 1A, let's take a look at the skeletons that you'll need to implement in order to complete the assignment. We'll start by taking a look at the array interface, which is in the utils directory in the image crawler package. As you can see, this interface extends iterable, which means that the implementation of the array interface can define an iterator. For assignment 1A, the grad students need to implement the iterator, but undergrads don't. For assignment 1B, the grad students and the undergrads have to implement the iterator. There's a whole bunch of methods defined here, which we'll talk about when we talk about the implementation class, unsynchronized array, which is defined here in this file. As you can see, the unsynchronized array class implements the array interface. There are several fields that are defined for you, including a static final field called default capacity, which is set to the value 10. If you define an unsynchronized array without providing any value to the constructor, it'll start out with a default size of 10. There's also a field called sEmptyElementData, which is used for empty instances to initialize. We'll take a look at that shortly. The two key fields that are defined here are the mElementData field, which is an array of objects, and also the mSize field. mElementData is going to be a dynamically allocated array buffer that will store all the array elements. And the capacity of the array, the unsynchronized array, at any given point in time is the length of this array buffer. mSize is the size of the array, which is a little bit confusing because that's not the same thing as the length of mElementData. The size of the array instead is the number of elements that are currently contained in the array. It also is used to indicate the next open slot in the array. So for example, whenever you call add, it will always place the new element at mElementData sub mSize. So this is a little subtle. We'll talk more about it when we talk about the actual implementations here momentarily. Those are the only two fields that you actually have to use in any detailed way and actually define in any detailed way in the implementation of unsynchronized array. Here's the constructor of unsynchronized array. This is called the default constructor. As you can see, it simply assigns mElementData, that field, to the value of sEmptyElementData, which as we saw here was just an empty array. Now we get to the stuff that you actually have to fill in. So you'll start by defining the unsynchronized array constructor, which takes a parameter to define the initial capacity. And as you can see here, there's initial capacity, which is the initial size of the array you're going to allocate dynamically. And you can also see that it throws the illegal argument exception. Inside the implementation of this constructor, you should first check to see if the initial capacity is less than 0. And if it is, you need to throw the illegal argument exception. If the value is 0 or greater, then you're going to set the mElementData field to a new array of objects of size initial capacity. So I'm assuming you can figure out how to do that. We then have the next constructor, which is essentially the constructor that's used to take a collection and be able to initialize an unsynchronized array for the contents of that collection. And so what you'll do here is, the first thing you need to do, of course, is check to see whether or not the collection reference that's passed as a parameter is null or not. If it's null, you need to throw a new pointer exception. If it's not null, then you'll need to extract the elements of the collection as an array, assign that to m element data, and then you'll have to update the m size field with the size of the collection. And so if you take a look at the collection, you should see a couple of methods that you can use here to do those things. So you just have to look around a little bit and see what makes sense. I want to make sure you learn enough about this to do it yourself without giving away all the code. If you take a look at the next method, this is a real simple one. This is just the isEmpty method. This returns true if the collection contains no elements and false otherwise. And all you're going to do here is just replace the return false with the appropriate code that will check to see if the array is empty. And so I'll let you figure out how to determine if an array is empty, but it's very simple. The next method is an accessor method called size. This simply returns the number of elements in this collection. This does not return the length of m element data. Instead, it's simply going to return the number of elements, which again, you can figure out pretty easily if you take a close look at the fields that are defined here. It's pretty straightforward. Let's now go take a look at the index of method. The purpose of this method is to return the index of the first occurrence of the specified element in the array, or the value -1 if this array does not contain the element. And the element, of course, is passed as a parameter, as object O. And what you'll need to do is replace return -1 with the appropriate code to implement index of. Now, this is a little bit tricky, and that's because there's really two cases. One case is the case where the object parameter is null, in which case you need to loop through all the elements in the array from 0 to basically index less than the size, the current number of elements in the array, m size, and check to see whether the ith element or the indexed element in the array equals null. So that's one way you need to do it. So if the parameter O is null, you do one thing. Otherwise, if O is non-null, then you're going to loop through all the elements from 0 to less than the size of the array, and you're going to check to see whether or not O equals the ith or indexed element in the array. So if you have a non-null object, then you'll use the equals method. If you have a null object O parameter, you'll use a check for null. And if everything goes through and you don't find a match, you'll just go ahead and return -1. Let's now take a look at the add all method. There's a couple of different add all methods. The first one takes a collection, the second one takes an array. And what basically add all does is it's intended to be somewhat of a concatenation operation. It appends all the elements in the parameter that's passed as a collection to the end of the array in the order that they would have been returned by the iterator, in other words, from beginning to end. Now, there's some verbiage here talking about this behavior being undefined. That's straight out of the Java documentation for list, which is what this thing ultimately is mimicking. And basically the idea here is that in some implementations of the array class, you could imagine having problems if you were updating the array as you were appending to it. It turns out, for the implementation we have here, you don't need to worry about this. It's just there for completeness. And instead, what you need to do is first check to see whether or not the collection is null. And if the collection parameter is null, you throw the null pointer exception. The next thing you'll do if you get past that check is you ensure that the array is big enough. And you would do that by calling the ensure capacity internal method with the appropriate parameters to make sure you've got enough space in order to grow this. And then the next thing you'll do is you'll use the system.arrayCopy method in order to copy the contents of the collection treated as an array into m element data. So you need to use system.arrayCopy and look and see how that works. Of course, you'll also have to update the m size field after you do all this. And then the return value indicates whether or not the array changed as a result of the call. And so you can do that by checking to see whether or not the size is greater than 0. Let's go take a look now at the next add all method. This works on an array parameter as opposed to working on a collection parameter. And it's very similar. Once again, you check to see if the array is null and throw new pointer exception or null pointer exception if it is null. check to see if the capacity is big enough by calling the ensure capacity internal helper method. And then once again, you use the system.array copy method to do the appending, and then update msize and return the appropriate result. So these are really cool methods, and you should avoid using loops when you implement them. Use the helper methods like system.array copy, which are probably optimized in many cases. The next method is the remove method, and this is going to remove the element at the specified position in the list or in the array. And what you're going to do here is pass in an index, and then the first thing you need to do is range check the index. So the index is not within range, and you would of course use the range check helper method to determine this. Then the index out of bounds exception will be thrown. Otherwise, you're going to go ahead and get the old element at the index location, and then you're going to go ahead and check to see whether or not you need to do a move, and you can do some arithmetic operations to determine if you actually need to do anything. And if you need to move everything, then you're going to call system.array copy, and you're going to copy everything down by the appropriate amount in order to take up the slot that's being removed. So it's basically kind of shifting all the elements down essentially by one in order to copy over the element that's being removed. And then you will return the old value. So you want to store that old value, copy things over to take up the space that's being removed, and then go ahead and kind of null out the element that is at the very end, because you'll have slid everything down by one to the left, and then return the old value. Here's the range check helper method. This is used to determine if an index is in range. And essentially what it does is it sees if the index that you pass in is non-negative and whether it's larger than or equal to the current size of the values in the array. This is not the same thing as the length of the array. It's the size, the msize field. And if the index is not within range, then you will throw the index out of bounds exception. If the index is in range, you just return and assume that the caller can do its thing, knowing that the values are correct. Let's take a look at some methods that use range check in addition to the remove method we just looked at. So the get method will be used to check to see whether or not the index is in range. You do a range check first, and assuming everything is in range, then you're going to index into the m-element data array using the index as the indice into that array, and then you'll cast the result that comes back, which will come back as an object, to something of type E using a cast. Set is somewhat similar. Once again, you start out by doing range checking, and once you can convince yourself that the range is correct, then you will go ahead and take the next set of actions in order to set the element in the array. So that's going to set the element at the specified position at the specified element at the specified index into the array. After checking that the range is correct, you then go ahead and take the old value at the index location in m-element data. You'll store it in a local variable. You'll then go ahead and update m-element data's index with the element that's passed in, and you return the old value. Let's now go ahead and take a look at add. Add is going to append the specified element to the end of the array. And so the first thing you need to do is make sure the array is big enough to hold a new element. So you have to make sure that it's going to be large enough to do that. Once you've called ensure capacity internal with the right parameters to make that assertion work, then you need to go ahead and add that element at the rear of the array, which of course will always be msize. Then you need to increment the size of the array by 1, and we'll always return true, because if anything goes wrong, then we'll find out through some other means. So that's essentially how add is going to work. Let's now go take a look at one of the more interesting protected methods. This is the ensure capacity internal method. And the purpose of this method is to ensure the array is large enough to hold the number of elements passed in as a parameter. And if it's not large enough, then it will go ahead and auto-expand the array. And we define this as protected for unit testing purposes. So the first thing you need to do is basically check to see whether or not there's enough capacity in the array to hold the existing elements that are in min capacity. And if there are, you're done. If there's not, you're going to have to go ahead and essentially figure out how much bigger you need to make the array based on the value of min capacity. And I typically do something like take the old capacity and double it. That's usually what I do. There's other strategies you can do, but that approach works pretty well. Then what you would do is allocate a new array of objects at the new capacity, copy the values from the old array into the new array, and then you'll go ahead and assign the old array, which is m element data, to new element data, or whatever you call this local variable that you use to allocate the new element data. So that's basically what you're doing there to ensure the capacity. And this is a very important method because it gets called all over the place in the implementation. There's a couple of methods I provide here as helper methods just to make life easier for the tests and some of your code. One just returns an unsynchronized array, and it also returns an unchecked array access. It doesn't actually do a range check. And those are used for various purposes. We'll talk about those later. There's also a few other methods I provide, one called toArray, which goes ahead and makes a copy of the current array and returns that as a built-in array of objects. That's useful for converting something from the built-in data type to, from the user-defined data type of an unsynchronized array into an array of objects. There's also yet another method called toArray, which is going to be used to essentially make a typed array. The first one you can see, the first toArray method returns an object array, so it's an array of objects. The second one is going to return an array of type T, a built-in array of type T, which is something that's a generic type. This also shows off a couple of interesting methods that may be useful, things like array copy, copy of. These are methods that you'll need to understand, at least the array copy method, you'll need to understand for some of the other parts of your code. So make sure you take a careful look at that and understand it. For example, the remove method we talked about before will need to do some variant of array copy, as will the ensure capacity internal method we just talked about. So this is all the things that the undergrads have to do. Now the grad students have some extra work to do. They have to implement the iterator. So the first thing you'll need to do is create the factory method that makes an iterator. And I think when you look down at the next nested class, you'll see what you need to do here. You need to make a new iterator. Here is what the grad students will need to do. You'll need to implement this array iterator class, which is a nested class. You'll need to define a couple of fields, and these fields will be used in order to determine the current position in the array. So it needs to be an int, defaulting to 0, starting at the beginning, of course, as well as the index of the last element that was returned. And that's needed for the remove method, as we'll see in a second. Let's then take a look at some of the methods that the grad students will need to fill in. There's a hasNext method, which returns true if the iteration is not finished yet. And so you'll need to replace the return false return value with the proper code that will check to see whether you're done. And you can check to see whether you're done by checking to see whether you've gone through all the elements in the array using the field you defined above to keep track of the current position of the iteration. There's also a next method, and the next method will return the next element in the iteration. And you can also see that it needs to be able to throw a no such element exception if something goes wrong. So the way I've implemented next is I use the get method, and that get method will throw the index out of bounds exception, which I catch and then rethrow as a no such element exception. So there's various ways to do this. I suggest you try to do it using the get method that you defined earlier. And one thing to note if you do that is you'll need to update the field that keeps track of the last value that you returned, and you'll also need to increment the position into the iterator by 1. And the last method that you need to do if you're implementing the grad student version with the iterator is you have to implement the remove method. And the remove method will first check to see whether or not you have a valid last return item. In other words, have you used your iterator at all yet? And if you have not, then the illegal state exception needs to be thrown. Otherwise, you'll go ahead and remove from the array the last item that was returned, which of course you would have set in this method right above, the next method, and then you're going to go ahead and update the position in the array and then reset the field that keeps track of the last value returned to indicate there isn't one at this point. So those are the key methods that you'll need to implement as the grad student implementation. You can also see that we have a stream method here that we use for testing. Right here, it just returns a sequential stream. We'll talk about streams in a later assignment. So that's basically it. You can see there's a lot of methods to implement. They're not particularly complicated, but you will need to think carefully about how to ensure the appropriate semantics. Now that we've talked about the specification for assignment 1A, and I've walked through the skeleton files to show you what methods you'll need to implement, let me show you how to run the unit tests. What you'll do is you'll go into your Android Studio project, and you'll click on Image Crawler, click on Tests, and you'll see there's a number of folders under here. What you want to do is you want to select the required tests folder and then right-click on it, which on my Mac is by Control-Shift-R. And what you'll see that happens now is it goes ahead and it builds the tests and it begins to run them. And you can see if the tests work, then all the different check marks are green. If they don't work, then the check marks will be a different color, orange or red. And at the top it says test pass 51 of 51 tests. And if you are curious, you can go ahead and click in here and you'll see that there's this test suite. And if you click around a little bit further, you'll find that there's something called Assignment 1 Tests, and that's what actually has the JUnit tests for the various methods that you needed to implement in the unsynchronized array class that you wrote for this assignment, which implemented the array interface. It's not really necessary to understand everything that's going on here. The key thing to note is the fact that you need to select the appropriate type of the assignment, whether you're doing a grad or an undergrad version, and that will then make sure that you have the right tests run. So you're welcome to look at this file if you'd like to, but the most important thing is to run the tests and make sure you get the correct results when you're done. There's one more thing I'd like to show you, which is how to actually run the app. In the next version of the shells, you'll have a one-button test to run this. It's called Android Test, but for right now I'm going to show you how to run it manually. What you would do is you would go ahead and run the application, which would be done by going to the menu here and clicking on Run App, and that will then prompt you for either creating or opening or using an emulator. To save time, I've gone ahead and opened the emulator. Here's what the program looks like. You can see it says Image Crawler. If you click on the little ladybug icon in the upper right-hand corner, it'll give you a bunch of options to select. And let's go with local so it doesn't actually go out onto the network, and download the files, which will just speed things up a bit. You can set the type of implementation you want. In this case, we only have one, which is sequential loop. We set the depth for the recursion through the directory hierarchy to 3. And then you can select various transforms. Let's turn on the grayscale transform as well as just downloading the image. There's a bunch of other things you can do to indicate whether you want to turn progress reporting on. You can also indicate the size of what's being downloaded. You can keep track of the state. You can indicate what thread is being done. You can also determine the speed at which you want things to be downloaded. You can set it to different speeds. We'll kind of give it a high setting here. And then we can also set a transparency for this particular window, so you can see whether you can make it transparent or completely opaque. So I think that's probably good enough for now. Let's go back over here and click the download icon. And as you can see, it's starting to download files. It's downloading the files one at a time. And you can see here that that's the original image that's downloaded. Now we're going to take that image and we're going to transform it. That's what the funny little filter is that you're seeing here. And this is keeping track of how far along we are in the transformation. Now that it's been transformed, it's writing it to disk. And you can see that this version here is the grayscale version. So we have the colored version and the grayscale version. Same thing has happened here. We downloaded the color image, and now we're in the process of transforming it with one of the transforms, the grayscale transform. You can see it's got a little progress bar. Now it's writing it to disk, and you can see it's in grayscale. And we could sit here for a while because it'll take a while to essentially download all these images and filter them sequentially, because this is the sequential version. You can see also here it keeps track at the top where it has the number of images that have been downloaded, how many threads are involved, how long it's taken so far to do all the downloading and transformations, and also which particular downloading crawler method, in this case it's sequential loops crawler, is being used. So this will take a while to run. I'm not going to sit here and run the whole thing. You will see when you start to do the parallel versions later in the course that things run substantially faster, because my laptop on which this emulator is running is actually a quad-core laptop, so it can actually do quite a number of things in parallel. Since I don't want to sit here and run this too long, I'm going to go ahead and stop it by clicking on the X, and that will go ahead and stop the downloading at that point. And that just gives you a sense of how to run the application. As I mentioned before, shortly we will have a one-button test that'll do all this for you, but this is just a way to know how you can set the options through the little ladybug icon and change some of the parameters here as you see fit.